While dedicated doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature for quick resolution of doubts even after your live classes. Just click on Ask a Doubt, type your question or click a picture of your doubt, highlight one specific question, choose the subject that the question falls under, and share it with your educator. While dedicated doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature. There are no silly questions, and we thrive on answering all your doubts. Just click on Ask
While
a Doubt.
dedicated
doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature for quick resolution of doubts and share it after your live classes. Just click on Ask a Doubt, type your question or click a picture of your doubt, highlight one specific question, choose the subject that the question falls under, and share it with your educator. Just click on While dedicated doubt-solving live classes are a part of every course,
Unacademy.
Ask a Doubt subject. There are no silly questions, and we thrive on answering all your doubts. While dedicated doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature for quick resolution of doubts even after your live classes. Just click on Ask a Doubt, type your question or click a picture of your doubt, highlight one specific question, choose the subject that the question falls under, and share it with your educator. Let's crack it.
Unacademy.
There are no silly questions, and we thrive on answering all your doubts. While dedicated doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature for quick resolution of doubts even after your live classes. Just click on Ask a Doubt, type your question or click a picture of your doubt, highlight one specific question, choose the subject that the question falls under, and share it with your educator. Let's crack it.
Unacademy.
There are no silly questions, and we thrive on answering all your doubts. While dedicated doubt-solving live classes are a part of every course, we also have the Ask a Doubt feature for quick resolution of doubts even after your live classes. Just click on Ask a Doubt, type your question or click a picture of your doubt, highlight one specific question. There are no silly
All right.
and we thrive on
Welcome.
answering all your doubts.
How are you all doing? I hope you're all doing good.
Unacademy.
This course is
We also have to Ask a Doubt feature for quick resolution of doubts
Alright.
even after your live classes. Just click
okay.
on
So I
Ask a Doubt.
welcome you to all for another session.
Highlight
This
one
is session
specific
number
question.
17.
There are no
All right. Just a sec. I'm just seeing still some.
Unacademy.
Let's
crack it.
You're all doing good.
Unacademy.
We also have to
Unacademy. Let's crack it.
Okay. So I welcome you to all for another session. This is session number 17. I hope it's clear now. I'm just seeing still. Okay, let's get started. Sorry about that. I was just trying to flip between the windows and was looking at getting this right. All right, so welcome to another session. We are going to do some interesting divisibility checks today, and we'll also do some short tricks on some small tricks on multiplication. We have done multiplication before, but I'll just tell you some other quick ones for multiplying by 11, 101 that you might find useful at some point in time. So welcome to this class. My name is Anup. I am a certified Vedic Math educator at Unacademy, and we are doing this YouTube series for the month of Feb. So some interesting stuff. You must have seen the Ask a Doubt feature at Unacademy, something that's available for both non-subscribers and subscribers, absolutely free of cost. You should try it out because doubts are an integral part of your learning, right? You should always have doubts. In fact, the people who have the most doubts learn the most. In fact, right, at some point in time, of course, you understand concepts, then you build on it, you ask doubts, you clear it, and that's leaves you no room for any assumptions, and your concept is clear. It's very important to have your concept very clear. And with platforms like Unacademy, you have access to unlimited content, and of course, with the if you take the plus subscription, you get a lot more benefits in terms of access to unlimited access to a lot of courses, access to top educators in India on one single platform. So a lot more benefits. So and do check it out. Do check out the Unacademy portal where you have insights. So I'm going to cover the first 5 minutes a bit on Unacademy to share what value Unacademy has. You can check it out if it works for you. There are new batches that are launched every Monday, and they've bring in a combination of educators to give you the maximum value for your time, right? So whether be it a combination of math and science, English and Hindi, social science, and bringing them all together, giving you the right content at the right time, right? So these are some subscription prices for the 9th, 10th, 11th, 12th. Do check it out. There's also iconic subscription, which is one level higher compared to a plus, because it offers you personal mentorship, personal guidance. You have your own personalized plan created for you. And there's a parent teacher connect as well, taking it one level higher for certain learners who probably want to get to their goal faster, or for some learners who take a little more extra time to get to their goal, right? So pick the one that's right for you. And of course, there's Creative Corner as well. Creative Corner is a place where you actually get to discover your inherent creativity, because there's lots out there in terms of skills that you can learn, be it doodling, music, magic, storytelling, Vedic Maths, robotics, coding, and anything and everything, right? Even communication and debating. So all these skills that make you a whole-rounded personality. So these are very important to have. I'm part of Creative Corner. These sessions that we're doing is part of Creative Corner. Creative Corner has their own subscription, and that's what you see here. There's a 10% off the subscription for the month of Feb. You can try my code if you want to really subscribe to it. Anup YT10. Start off small, and then see if it works out for you. Okay, so with that brief introduction on Unacademy and what features are there in the platform, let's start this session today. We have a couple of topics. We'll plan is to have a 1 hour session today. Okay, so it's going to be slightly longer than the sessions that we had before, because we are trying to wrap up all the content for the month of Feb. So this being a Saturday Sunday, so we thought it is okay to put 1 hour here for of course you can listen it in 2 parts. I know a lot of you listen this in the form of a recording, so you might be you have the luxury of pausing and revisiting whenever you get time. Okay, so but we will do this session one go at for 1 hour. Okay, so we are going to do some divisibility checks, right? Yeah, so divisibility checks, let's look at it, and I'll show you the tables. We're not going to cover all the numbers 2, 3, 4, 5, 6, 7, 8, 9, right? Divisibility checks by that, basic ones. We'll cover some things where it's difficult to find the divisibility, and that's where I'm here to help you to find out the ones where it's difficult for you to find divisibility. Okay, we look at multiplication by 11, multiplication by 101. These are very, very easy basic ones. Some basic algebra multiplication. Okay, we will use the vertically and crosswise method. And then we will also look at multiplying 3 two-digit numbers. We have seen 2-digit by 2-digit multiplying using the vertically and crosswise. If you've not seen that, I highly recommend you watch that video. We have some separate videos created just for multiplication. So we're going to extend that, use that here, and derive 3 digits. What do you have 3 digits to multiply? Okay, so let's get started. So most of you would know, right, to check 2, 3, 4, 5, 6, 9, 10, and 11. So, and I've tried to put this down here. 2, of course, if it's an even number, it's definitely divisible by 2, right? If it's, and I'm not going to cover these actually. My interest is to cover certain numbers here, 7, 13, and I will also cover 19, and then combinations of that, okay, which are difficult to get from these, and there's no set pattern that would have been taught to you. Okay, divisibility by 3, the digit sum, basically if you sum the digits, and if it's then if it's divisible by 3, it's divisible by 3. There's a method for 4 as well, right? Adding the last digit to twice the penultimate, and if the number is divisible by 4, then it's divisible by 4, right? So but I'm not covering these, are just for your reference. Okay, my interest is to start with 7 and other numbers that are difficult to find. Okay, 8, 9, 10 is very straightforward, 5 is very straightforward, 11 also you must have seen, right? If the difference between the sum of the digits in the first, third, and fifth place, basically the odd and even digits, if you sum all the odd digits and subtract it from the even digits, then if it's a multiple of 11, then it's it's a divisible by 11, right? Yeah, 11 here. Okay, 12 is easy. You check divisibility by 3 and 4, it's divisible by 12. But let's look at some interesting ones here. Okay, Before that, we need to revisit. We did this in some of the previous classes. Now, for those of you who are not familiar with it, that's okay. I'm going to explain again. You got to know this term ekadika. Okay, ekadika means essentially in Sanskrit it is by one more. Okay, by one more than the one before. Now, what it essentially means is, and if you go through these three examples, you'll be thorough with it. Okay, if I say I'm trying to find out the ekadika, it's a property of the number. Okay, the ekadika of 29 is 3. How did I get 29 is 3? Because what is the number, and it is specifically for the numbers that ends in 9. Here in this case, that's what we'll do. Ekadika is one more than the number when the number ends in 9, or a series of 9s, right? So what is the number that is before 9? It is a 2, right? And what is one more than 2? It is a 3. So that's how you get this, right? 9 here, what is the number before 9? 3. What is 1 more than 3? It is 4, right? Ekadika of 49 is 5. You got it right. 4 plus 1 is a 5, right? So it's clear. I'm just going to check if my streaming is on. I hope you're all listening to me and hearing me, because if that's not on, then that's a problem. At some point in time, once I've had that issue where I was talking and then the streaming was not live, which means obviously you're not hearing this as well. Okay, so the session is going on. No problem. So I'm happy. All right, just worried. Okay, so we found out ekadika. So I hope that's clear, right? Finding the ekadika is clear, right? You've if the number is, I'll give you one more example. What will be the ekadika of 19? Ekadika of 19 will be, so this is the number, and this is the ekadika. Ekadika of 19 is 2. Ekadika of 69 will be easy, right? 7. One more than 6, right? One more than the number before 9. So in Vedic Maths, all these concepts, right, all whatever, it's very, very basic to understand. It's not at all difficult. If I tell you how to do it, you'll be able to do it. Okay, of course, when you find out first, when I ask you, how did I find out, it's a little difficult to derive it. There's a little mystery behind it. But if I tell you that secret recipe of how to get it, it's very easy for you to do it by yourself next time. Okay. All right. Now we're going to talk about this oscillation method. Okay, this is what we will use, and remember this term oscillation. Okay, we will use this like a kind of pendulum kind of thing, right? So that's why I put this down here. We will use to test this. This is a divisibility by 7 test. Okay, so I'm going to find out if 91 is divisible by 7. Okay, so that's my problem here. Okay, is 91 divisible by 7? So my very first step is I'm going to find out the ekadika of 7, right? What's the ekadika of 7? Now you must be wondering, there's no 9 here. How do I find what's the number 1? What's the number before, right? So it has to end in a series of 9, okay? So what I will do is I will convert this to ensure that it ends in a 9, right? I will convert it by multiplying something so that it ends in a 9, okay? So if I multiply 7 is the smallest number, okay, that you can multiply, that will end in a 9. Okay, that number is, if I multiply 7 by 7, I will get a 49. Now I know when I get 49, find out the ekadika of 49, which we did before, right? The ekadika of 49 is 5. How? Because what is the number 1 before 9, which is a 4, plus 1 of that is 5, right? Oops, got it a little bit. Let me write that down clearly. So I got 49. Yeah, I got 49. One more than the number 1 more than 9 is a 4, plus 1 is a 5. So now my ekadika is 5. Now I'll play around with this number. So I'm going to test divisibility of 91 by 7 using this ekadika of 5. So I'll put 9 and 1 here. Okay, 9 is here, 1 is here. So my very first step, now this is a series of steps that you follow. Okay, now there is a reason why this is, we are not going to go in deep in that, because the founder of Vedic Maths, Swami Bharatiya Krishna Tirtha ji, has done a lot of research, and he's found out patterns. Okay, so the gift that he has given us is these patterns after a lot of research. Okay, and these patterns have been proven. They will always work. It's like a law. It will always work. Okay, it's a universal law. It will work always. Okay, so 91. So I have 91. Now what I will do is I will multiply by 5. 5 is basically the ekadika. So I will always multiply the last digit, okay, that one, by 5. And then I will add it to the first digit. When I add it to the first digit, what happens? So I multiply 1 by 5, right? The ekadika that I got, right? And then I will add it to this digit. I will add 9. So when I add 5 plus 9, I get 14. That's where the magic happens now. So you got 14. All you need to check is if 14 is divisible by 7. And you know the answer. 14 is, we know 14 is divisible by 7, right? So this number is also divisible by 7. Okay, now you can go one step further. You can also check 14. Again, you can do an ekadika. Again, you can do the same process here. So I got 14. My ekadika is 5, right? So I multiply 4 into 5 into 5. I will get a 20. I will add it to a 1. What do I get? When I add that, I will get 21. So 14, 21, next step, 14, 21 is also divisible by 7. So you can do again ekadika, or you can do that same process on 21 also. See, if you do that, you don't need to do that. I'm just telling you. If you do that same process, you multiply 1 by 5. Right now, see what happens. You multiply 1 by 5. What do you get? 5, right? And then you add it to 2. 5 plus 2, you get 7. So you obviously know 7 is divisible by, so 7 is definitely divisible, right, by 7. So 91 is divisible by 7. You don't need to do all these steps. You know that 14 is, you got it in this step itself, right? So that's the beauty of this method. You can try it with longer numbers also. The same pattern will follow. We'll do some longer numbers as well. Now these are 2 digits, right? Pattern will continue for longer numbers as well. Okay, so in this way, you're able to find out the divisibility by 7. So let me just quickly recap. Okay, clear all this for you. Okay, what did we do? We found out, we are trying to find out if 91 is divisible by 7. Okay, so now first step is to find out the ekadika of 7. That's the first thing that you need to find out. So if I need to find out if the number was ending in 9, it was easy. But since the number is not ending in 9, what I will do is I will try to convert it to a 9, some number that is ending in 9. So I will multiply 7 by 7. I got 49. So now I know the ekadika of 49 is 5. So I will use 5 now. So now I'll start my thing with 5. So I will take this 91. I will multiply by 5, right? That ekadika I multiply by 5 and add it to this digit. You can actually, I'm writing all this, but you can do it in your head also, right? If any numbers, you can actually do it in your head. And if you get this number that is not divisible by 7, then you can be sure that this number is not divisible by 7, right? If you take another example, for example, let's take 81, right? So now, is 81 divisible by 7? So what I'm going to do is I will write 81 here and I will multiply 8. My ekadika is 5 only, okay, for that. So I'm getting what? 5 plus 8, I will get 13. And you know that 13 is not divisible by 7. So this is ruled out. This is not divisible by 7. So it's very easy, right? So you can actually do it in your head itself. So this is a very beautiful method that is, okay. All right. Yeah. Okay. So let's look at another one. Find out if 78 is divisible by 13. Okay, now again same thing, you got to find out the ekadika of 13. So I found out the ekadika of 13 is 4, right? Some of you can guess it already how I've done that, or I've written it here, obviously here. So I convert it to some number that is ending in 9. I multiply 13 into 3, I get 39. The ekadika of 39 is 4, right? One more than what is the number 1 more than 9? That is a 3 plus 1 is a 4, right? So I've got that. Now I write down 7 and 8, right? 7 and 8 is the number I'm trying to test. So I multiply by 4. When I multiply 8 by 4, I get 32. I add it to 9. I add 9, right? Sorry, not add 9. There's a mistake that I've done here. I should add 7, right? Because that first number is 7. I added by this first number. So 32 plus 7, I get 39. Now, if you want to know if 39 is divisible by 13, it is obviously 39, yes, is divisible by 13, right? 13 threes are 39. You can test it again if you want. Okay, put 39 again, multiply by 4, 9 fours are 36, add 3, you get 39. So if you get the same number even after doing one more oscillation, the repetition indicates that the number is divisible. Okay, so that's also another easy way to verify. If you don't know that 39 is divisible by, if you don't know that 13 threes are 39, you want to test it again, you get again another 39. So you can be very 100% sure that this number is divisible by 13. Okay, so I hope you've got it. Maybe you can just play back and rewind if you need to do just understand this, because but once you get it in your head, it's not very difficult at all. It's going to be very easy for you to find out 7, 13. Now let's look at one more example here. Do I have this as a second example? Yeah, okay, this is a second example, right? Okay, all right, 6. Okay, all right. Just ignore this part. I think I had pasted it from that other section, so you can read through it while I'm just coming back to you. We are testing 86 divisible by 13. All right. Okay, so we are testing 86 divisible by 13. The Ekadika is 4. I multiply 6 into 4, 24. I add it to 8, I get 32. Now, is 32 divisible by 13? No. All right. So 86 is not divisible by 13. You got your answer then and there, right? 86 is not divisible by 13. Okay. Let's look at a longer number now. Okay, now I put some colors here. Don't worry about it. That colors is meant to help you, figure out which number I'm multiplying when I tell this, right? So now find out if 247 is divisible by 19. See, in a normal, process, what I've learned in school, I'm not sure if you'd be able to get this so easily, but here you're going to get it very easily. Okay, so the Ekadika of 19 is 2. All right, so I know the Ekadika of 19 is 2. So now I've not written all those arrows and all because I'm trying to simplify it, so you need to do it in your head now. So what I do is the Ekadika of 19 is 2, so the last number 7 I multiplied by 2, right? So that's the first step. 7 into 2, I get a 14. I take 14 and add it to this 4, this digit, and I put it right below that, 18. Okay, I've got 18 now. Now you got to repeat that step because there's one more digit you got to worry about, right? So now I take 18 and multiply by Ekadika, I get 36. I plus add it to this, 36 plus 2, which is a 38. So I've got 38 now. So now you can test it. You know that 38 is divisible by 19, right? 19 twos are 38. So this answer, yes, is divisible by 19, right? So that's all. So even if longer numbers are there, you keep doing that Ekadika, multiplying by the Ekadika and then adding it to the next digit, right? So multiplying it by the Ekadika, here this 2 is the Ekadika, right? This 2 is this 2. That's what I've put it in red here. See, the Ekadika of 19 is 2. So I'm multiplying 7, the orange number, by 2 and adding 4, this purple number, to get 18, right? I've put 18 here. Then I take 18 and I multiply by Ekadika, again this 2, and add this 2 here. What do I get? 38, right? So 38, you can check if it's divisible by 19 or not, right? If it's divisible by 19, yes, this number is divisible by 247, right? 247 is divisible by 19, basically. Sorry, 247 is divisible by 19. So now I'll give you an alternate slightly easier. I'm trying to make this easier. Okay, suppose you have longer numbers here, now the multiplication becomes also difficult. So I'll give you another trick which will make it a lot more easier for you to do, even more easier than what you're doing now. Okay, so it's already easy, right? So when you see this, right, I'm multiplying, let me do it in a fresh slide. Okay, so here what I'm checking, 247 divisible by 19. That's the question, right? So I find out the Ekadika is equal to 2. I hope you all will agree to it, right? Ekadika of 19 is 2. So I put all two. I've written this 247 here. So my very first step is multiply the Ekadika by this number, last digit, right? 7 into 2, and add it to this digit and put it down here, 18, right? Because 7 into 2 is 14, 14 plus 4 is 18. I add 18 here. Now I'll tell you that, you know what, now next step, what I told you to take this 18 and multiply by the Ekadika again and add it to this. This is what I told you, right? 18 into 2, 36, 36 plus 2, 38, right? And you find out if 38 is divisible by 19. Yeah, you're happy, answer is there. So I'll tell you what, you don't need to do this. You don't need to take all the two digits. When you get 18 here, multiply only this 8. Okay, 8 by that flag. So multiply only that 8. What do you get? 16. Then you add this digit here. Then you add that 1. Okay, when you add 16 plus 1, you get 17. Then you add it to 2. 17 plus 2. You get 19. Now you can check if 19 is divisible by 19, which is yes. So you don't. So basically, no, your numbers will come down. The bigger numbers will come down. You will be dealing with smaller numbers. So 19 is divisible by 247. So there you have your answer is there already. Okay. So I hope it's clear, right? I don't have feedback, unfortunately, not a lot of you in the session today, so I can't really comment if you're getting it or not. But I believe if you watch this video a couple of times, you should be able to get it right. Okay. So let's look at a few more examples. Okay. Divisibility of 4617 by 19. Okay. Watch this very carefully. Let's see how many slides do we have. We have a couple of more examples. I've put in as many examples as possible. Just 3 more examples and then we get into multiplication by 11. Okay. All right. So 4617 divisibility by 19. So the Ekadika of 19 is 2. That's a given, right? I hope by now you would have understood, right? So the very first step is what I do. I multiply 7 into 2, which is 14, plus 1, right? So I got 15. Now I'm going to use that single digit multiplication technique only. I'm not going to multiply the whole digit, okay? Because I want to deal with smaller numbers. I love dealing with smaller numbers, right? Why to deal with the longer numbers? So now I got 15. So I will multiply this 5 by 2, add 1, right? So 5 into 2. So this step was 14 plus 1, which you got 15. Okay, so this circle I got. I'll write where I got. Now I will take 5 into 2. So my next step is 5 into 2, which is a 10. I'm multiplying only the last digit, okay, not the whole one. Then I'm adding 10 plus 1, I get 11. Then I take 11 plus 6, I get a 17. So I got this digit also now. Okay. Now after this, I will take 7 into 2, which is a 14. Right, then I should not forget to add that 1 which I left over there, right? 14 plus 1, which is a 17, right? Plus 1, which is a 17, right? Okay, and then I take that 17 and then add it to a sorry, just there is some yeah, okay, got it. You know what the silly mistakes is. What sometimes what did I do here? I did 14 plus 1, which is a 15. I was going in circles, just wondering what happened. So then I take 15 plus 4 and I add it to I get a 19, right? So that's that last 19. So I got 15, 17, 19, right? So I know now 19 is obviously divisible by 19. So 4617 is divisible by 19. So let me write this again for you, okay? I kind of paused in between because I made a small silly mistake. I wrote 14 plus 1 as 17 instead of 14 plus 1 as 15. So that's why I'm going to redo this again, just so that I absolutely don't don't like anybody to have any doubts in their mind, right? So 4617 divisible by 19, ekadika of 19 is 2 given. Okay, so my very first step is take 7 and multiply by 2. I get a 14 and add it to that 1, 14 plus 1, which is a 15. So my very first 15 is, I've got this first 15. Now I take only that 5 and multiply it by that ekadika, right? I get 10, right? And then I take that 10 and add it to that 1 which I've missed over, right? I get 11. I take that 11 and add it to this 6, right, which I get a 17, right? So I got my 17 as well. All right, now I take 7 and multiply it by 2. I got 14. I'm taking only that last digit, remember? I take 7 multiply by 14, I get 14. I take 14 plus 1, I get a 15. Okay, this is where I made that mistake. I did 14 plus 1 is 17. 14 plus, then I take that 15 and add it to this 4. I get a 19, right? So this might sound a little, you're dealing with all the numbers, but actually you can, you can actually do it in your head, right? It's not difficult. You can actually do it in your head itself, and you can write it down. Maybe you can write down the last each digit. You can write down as and when you get it, right? And then you can operate on this and say that, okay, you know what, 19, yes, the number is divisible by 19. This is a very beautiful method in Vedic Maths that teaches you how to deal with numbers and certain divisibility tests very simplistically. It's a very simple method. Okay, it took me a while to understand, but over practice, at least my concept is clear. I'm very clear of in terms of the pattern is clear for me. I know exactly what I should be doing, right? Just ensure that we don't commit any silly mistakes while doing this multiplication and addition. That's all. If you're not doing that, then you are certain to get the right answer. Just requires focus, because these operations, as you see, these are small operations, very easy to do these operations. We all know this. We've been doing this for many years, right? Multiplication, addition, basic addition, right? Suppose I made a mistake here. Mistakes do happen, but ensure that as soon as you recognize it, see, I recognized it quickly and I corrected it, right? That's important. Okay, now interesting. Let's look at divisibility by 23. Now you'll be wondering, you know what? I'm now able to expand this method to do a lot of more stuff, right? So how do I do this now? See, 23, I'm going to convert it to, I told you, right? I'm going to convert it to a number so that it ends in a 9. So 23 3s are 69. So the ekadika of 23 is 7. Okay, so now I'll start my operation here. So let's do it one by one here. Okay, our test is 1, 3, 4, 5, 5 is divisible by 23 or not. So let's look at it. The very first step. Remember, my ekadika is 7. So everywhere I'm multiplying by 7. This digit by 7, adding it to this digit. Right? So 5 into 7 is equal to 35. 35 plus 5 is equal to 40. So I've got that 40 here. Okay. See, now notice this, I'm starting, unlike here I was doing it in 2-3 lines. Now I want to bring you to a get you to a habit where I'm doing it in one single line. Okay, so now I take only the last digit. Okay, so I told you we're not taking both the digits, I'm multiplying, taking only the last digit. So I multiply a 0 into a 7, which gives you 0, right? Plus you should not forget that 4 that you left over. So 0 plus 4, which is a 4. Then add it to this 4. 4 plus 4, which is a 8. So you got that 8. Okay. Now I will take 8 and multiply it by a 7. I will get 56. 56 I add it to this 3. I get a 59. So this 59 is also obtained. Now I take 9 and multiply it by a 7, which I get a 63. 63, right? I've got a 63, right? Yeah. So 63, I got to add it to a 5, right? I've left out that 5 here, no? So 63 plus 5, which is a 68, plus 1 here, which is a 68 plus 1, which is a 69. 9, right? So that's that 69 that I've got. I know that 69, is it divisible by 23? Yes, it is divisible. So 1345 is divisible by 23. Okay. I'm not sure if you need a recap on this, but I'm willing to do a recap. We have some time today, so okay. Trying to repeat some problems sometimes, if I repeat it twice, you get the, because sometimes there must be some small step which you not understand. How did I get 40? How did I get 8? How did I get 59? How did I get 69? Right? So we're going to solve that again here. Okay, so your ekadika is 7, which is very clear. I take this 5 and multiply it by 7. I get 35. I then add 35 to 5. I get a 40. So very important, this 40 is all clear. We've got it here, right? So let me circle all these 40s that I'm getting, right? Draw a line here. Now I will take only the 0, right? 0 and multiply it by a 7, right? I get a 0, right? Then I will add that 4. Don't forget that 4. 0 plus 4, which is a 4. Then I will add it to that next number, no? 4 plus 4, which is a 8. So that's how I got 8. 8 is clear, right? Next, I take 8 and multiply it by 7. I get a 56. 56 I add it to a 3. I get a 59. 59 is also clear. Next, I take 9, right, and multiply it by a 7, which will give me a 63. Then I should not forget that 5 which I left there. 63 plus 5, which is a 68, plus that 1, 69. So 23 is divisible by 1345, because 69, as long as this number, whatever final number you're getting, is divisible by this number, you can be 100% sure that this number, whatever you're testing on, is also divisible by that number. Okay, by whatever number you're testing, right? So while these steps might look a little difficult in the beginning, it is the best method that is there available today for you to test divisibility. Okay, because I'll tell you what, this also extends to other forms of so let me give you another example why this is so powerful. If you're looking at 6308, is it divisible by 38? I know that 38 is composed of 2 into 19, right? We all know that 38 is equal to 2 into 19. So if I need to test the divisibility, I can test the divisibility of 2 and I need to test the divisibility of 19. If they are divisible by both numbers, then this number is divisible by 38. Now you know for sure that it's clearly divisible by 2, right? 6308 is very, very clearly divisible by 2. Now let's check the divisibility by 19. And this is a method that we have done all this while ago, right? Previously we were doing this only, no? So 6308 divisibility by 19, what's the ekadika? 2, right? So my very first step is 8 into 2, which is a 16, right? So 16 plus 0, which is a 16. So that's my first 16, right? Then I take that 6, I multiply it by a 2, I get 12, right? 12 plus 1, the number which I left over here, I get a 13. 13 plus this 3, I get a 16. So the 16 is also clear. Now I multiply that 6 into 2, which is a 12, right? 12 plus 1, 13. 13 plus 6 is a 19. So yes, this number 19, it's very obvious that you can easily figure out that you're testing the divisibility by 19, right? So if 19 is divisible by 19, then this number is also divisible by 19. And since we told, right, it's if you test it by 2 and 19, then the number is also divisible by 38. So see how this has applications where you can extend it to other numbers, where you can try to find it out as a combination of any number that you can try to find the ekadika of, right? By doing that multiplication by 9, you can crack divisibility problems very easily. Okay, so all right, so I think that's just a quick recap, we were focused on checking for divisibility of C. We didn't cover obviously 2, 3, 4, 5, 6, 8, 9, 10, 11. These are very basic ones that are available. You can follow the textbook, whatever you've been doing. But what sometimes we are not being taught is divisibility by checking of these some prime numbers, right? 7, 13, 19 and all that. So that's where I'm this method that I just told you now helps you do that. The very first concept you need to remember that is Ekadika, right? Ekadika of 29 is 3. Why? Because you find out the number before 9, one more than that number before that 9. That's all. That's the simple concept of Ekadika. And we follow this oscillation method where we use this Ekadika. We take that 1, multiply it by that Ekadika and add it to its neighbor there, right? And whatever resultant number you are getting, if it's divisible by 7, you will get a smaller number. Okay. The idea is you will get a smaller number that you will be able to find if it's divisible by 7. Okay, and you will getting 14 here. You know 14 is divisible by 7. As a result, 91 is divisible by 7. All the problems that I told you here is following the same pattern, except here, you know, where I told you one easy method. When you get long numbers, you multiply only by that last digit, then add this digit and then add it to the next digit. You know, that's how you get it, right? So in this case, for example, when you were multiplying by, you know, you don't need to multiply 18 by 2. You can just multiply 8 by 2, 16 plus 1, right? Which gets you a 17 plus 2, which gets you a 19. So that's instead of 38, you can get 19, and that also is the right answer. Okay. All right. So that was just quick recap. Let's quickly do multiplication by 11. Now this is a very easy one. Let me just try to play some animation there for you. Oops. Okay. Okay, so multiplication by 11 is very easy. Okay, so if you look at it, right, just watch this animation now play out. Okay, so the answer, the first digit is the same as the first digit of the multiplicand. You got half your answer there, and the middle digit is what? The sum of both the digits together. So 45 into 11 is 495. Your one part of your answer is 4, your first part of your answer is 4, your last part of your answer is 5. The same digits there. The middle number is the sum of both the numbers together. So let's look at another example. 36 divided 36 into 11. So the first and the last digit is clear, right? The middle digit is 3 plus 6, which is a 9. Okay, so now let's look at one more example. Okay, when sometimes there will be a carry. Okay, so what happens when you get this, right? You know that you got it. You got 3 plus 8 is a 11, right? So when you do 3 plus 8 is 11, you can't obviously write 3118. Okay, there's one units digits. That one digit is a units here, whatever that place in your tens place. That one is of the higher power, so it has to get carried over to the next so let me just write it down. 38 into 11. So when you're doing 38 into 11, so you got 3 and 8. You all agree with that, right? So 1, this 1 gets added over here. Okay, so that answer is basically 418, right? So that's how you get your answer. Okay, because this gets added to this number, so this becomes 418. Okay, so it's very easy. As I said, half the answer lies in the question itself. So multiplication by 11 should come in a jiffy. It should not even take 1 second or 2 seconds at the max, tops, not more than that. In fact, it can be less than 1 second, right? What say 45 into 11, 495. Why? 4 and 5 is there. 4 plus 5, 9. That's it, right? 36 into 11, 396. Why? Because 6 is there already. The middle digit is 9. 3 plus 6, 9. Right? Of course, when you have carry, you got to do that. Ensure that you don't forget that carry. Carries are very important. You got to keep that on the side. Bring it to that next number. So 38 into 11 was 3 and 8. 1 is a carry, so that becomes a 4, 1, 8. Okay. So you can also check divisibility 11. Interesting, right? Because if you see here, right, 396, you know that, you know, this is definitely a number which is divisible by 11 because the middle digit is the sum of both the digits, right? If you see, these are, you know, sometimes these are things that might help you solve a problem very fast, right? You, by simple observation, you know that these numbers can be divisible by 11. It's definitely divisible by 11, right? Because that middle number is a sum of both the outer digits. Okay. All right. Let's look at multiplication by 101. This is also another simple property. When you have 23 into 101, the answer is 2323. Repeats itself. This 23 repeats itself. 2323. 69 into 101 is 6969. Okay. 123 into 101. The only difference here is, see, now you got to see that this is a base of 100. Okay, so you're actually allowed only two digits, right? When it's a base of 100, you're allowed two digits. This one gets carried over into that thousands place. Okay, so units and tens, hundreds place here, sorry. So you have 123 and then 123. So this one gets added here. So this becomes 12423. So now you can check this for yourself why this works, right? Because 23 into 101 is what? 23 into 101 is 23 into 100, right? First of all, which is a 2300. Then you have to add another 23 to it. So when you add this, you will always get like this, no? It will always be lined up like this, 23, 23, whatever you do, right? So this is a unique thing, right? Sometimes we don't observe it, but it's very easy. So suppose you get any multiplication by 101, you know that you can crack it very fast just by looking at it, number itself. It's probably milliseconds you can answer it, right? So look at this example, 223 into 101, right? So you write 223, 23, that 2 gets, because see, look at the base, how many zeros, I mean this base is of hundreds, right? So units and tens, right? Units and tens, you're allowed two digits here, units and tens, right? This one gets carried over into this. So 223, 2253. Now suppose you get another one where it says 0, 47 into, there are, three digits in the there are three digits here, so you're allowed three digits, that's okay. 047, 047, that's all. That's how you write it, right? 047, you are allowed three digits, right? If there are two digits, you're allowed only two digits. That one will go into the carry. If there are three digits here, if it's a thousands place, you're allowed three digits. So again, you can see why this works, right? Very easily. It's 47 into 1001 is equivalent to 47 into 1000, which is 47,000. Then you're adding another 47 to it. That's all, right? 47,000 times 1001 times, right? So then when you add it, what you will get? You're going to get the same number, right? So it's very easy, very, very easy. 101, 11, as I told you, half the answer lies in the question. In Vedic Maths, a lot of things are actually, beautiful, because you, again, 50% of the answer you get from the question itself. Okay. Okay, let's look at some basic algebra multiplication. Okay, let me just take a sip of water. Been 45 minutes since I've been speaking, so. Bring some light as well. I'm sorry, lighting was not. Okay. All right, so we're going to do some basic algebra multiplication now. It's very basic algebra multiplication, not at all difficult. If you're familiar with the vertically and crosswise method, then this should be easy for you. Okay. All right, so 3x plus 4 into 2x plus 5. Okay. Normally, I know how would you do it, right? You would take 3x multiplied by 2x, 3x by 5, 4 into 2x, 4 into 5. Easy answer, not difficult at all. You can do it that way, or you simply follow the vertically and crosswise method, right? Just like how you do a two-digit multiplication. It's the same thing. See, arithmetic and algebra, there's no difference, right? It's actually the same, just that you use a variable here, x or y or z, and then you manipulate, right? Because you are writing 23, you can write 2 into 10 plus 3, which is also equal as 2x plus 3, where x is equal to 10, right? Right, if 2x plus 3 is equal to 23, you know x is equal to 10. That's how, that's very basic algebra 101, right? So algebra is arithmetic only, nothing different. It's just that you represent it and you can change x. Suppose x is equal to 20, the value changes, right? So that gives you, flexibility of doing that. So that is why the vertically and crosswise method applies here as well, just like it applied for arithmetic, right? So here in the vertically and crosswise method, the very first step is multiplying these two sides, 4 into 5, which you get a 20. Then you multiply it crosswise, 3x into 5, 15x, plus 8x, you get a 23x. and then you multiply these two, 3x into 3x, 6x squared. That's it. So this was like super easy, right? And I think your algebra multiplication, no, sometimes you get so feared, you know, you're looking at this number of terms are high, right? So we get worried, right? So take your fear out of algebra. There's a lot more we can do in Vedic Maths on algebra. Probably I'll find time to create another session for it. I don't know, at some point in time in future, a dedicated session for Vedic Maths in algebra itself. A lot of useful tricks, because all what we learned in arithmetic can be applied here as well. Okay. So I hope that was clear. Just going to repeat that one last time. For those of you not familiar with vertically and crosswise method, I highly recommend that you check out some of my previous videos, because I've explained that in detail there. We've covered a lot more examples. Okay, so you're multiplying 3x plus 4 into 2x plus 5. So very first step is, this is the pattern for maybe I should draw that to make it clear. So you multiply this vertically, then you multiply this vertically, and then you multiply this. That's all. This is a simple pattern that if you remember this, 4 into 5, 20. Then you crosswise 3x into 5, 15x plus 8x, which is a 23x. So that is this. This is when you got it. And then 2 into 3, 6. X into x is x squared. So that's 6x squared. Right? Beautiful. Easy. Okay. All right. I think this is the last topic for today, multiplying 3-digit numbers, and probably do 1 or 2 more examples, and then we can kind of wrap it up for today. But now you suppose you have a problem 21 into 43 into 65, right? Again, this follows the vertically crosswise method itself. We have talked about, multiplying, just before example was, what 2-digit multiplication, you follow this pattern. This is what I told you, right? This pattern, right? Oops. This pattern, right? This is the pattern that you follow for vertically and crosswise. So let's just use a similar thing only here. So our goal is what? To find out first the units digits. The units digit is easy. You multiply all the units digits together, you get your units digit, right? So I'm going to get my units digit. So my very first units digit is 1 into 3 into 5, which is a 15. You all agree with that? I hope that's easy, right? Now you will find the tens digit, right? Units place I've got. Now I'll find the tens digit. So now I'll take this number and forget this, what is at the same level of it. I'll multiply by the other 2. So 2 into 3 into 5. Okay, that's what I've written here. 2 into 3 into 5. This dot means multiplication, just to keep it very clean. Okay, 2 into 4. I had not used the crosses, so just remember this dot means a multiplication there. Okay, that's all. Okay, so 2 into 3 into 5 plus 4 into 1 into 5. Skip this one here. That's at that same level. Plus 6 into 1 into 3. So I've got 68, right? So again, you're finding the tens place. Tens place by units place. When you add all the tens places by the units place, you get the tens place, right? Overall tens place. So 2 into 3 into 5. 4 into 1 into 5. 6 into 3 into 1. So except skip the digit that it's this level and multiply by these 2 digits. Add these two. So 2 into 3 into 5 plus 4 into 1 into 5 plus 6 into 1 into 3, right? So I got 68. So write 68. So I'm writing these numbers. I'm not doing any, I will deal with the carries later. Okay. My intent is to deal with the carries later. I'll first write down whatever numbers I've got here. So I got 15, I got 68, right? My hundredths digit. So now how do I find my hundredths digit? I multiply 2 tens digits, right? 2 tens. I multiply the units and 2 tens together. I will get my hundredths digit. Okay. So I take 1, 4 and 6, right? 1 into 4 into 6, 3 into 2 into 6, 3 into 2 into 6, 3 into 2 into 6, plus you can guess it 5 into 4 into 2, right? So I've got 100. So this is how I'll write 100. Okay. Then my last one is 48. That is easy. My thousands place. Tens place, tens place, tens place. I multiply all that. I get my thousands place. I got 48. Right. So now this 48 gets added here to 10. This becomes a 58695. That's your answer. Of course, we took some more extra time because I had to explain all that to you, step by step. but it's pretty straightforward. Okay, so let's look at one example. 22 into 14 into 13, right? So I first multiply all the units place. 8 into 3, right? 4 into 3 into 2, 24. Then I multiply by the remember, by the tens place with the units place to get all the tens places. Okay, so 2 into 4 into 3, right? 2 into 4 into 3, which is 12 into 2, 24, plus 1 into 2 into 3, which is a 6, plus 1 into 2 into 4, which is a 8. All right, so what is this? 30 plus 8, 38. Then I multiply, I'm taking the units place and multiplying by the two tens place to get the hundreds place. So 2 into 1 into 1, which is a 2, plus 4 into 2 into 1, right? 4 into 2 into 1, which is a 8, 3 into 2, which is a 6. So this gives me a 16. And then how do I get my thousands place? I multiply all this together. 2 into 1 into 1, which is a 2. So my answer is 3. This one goes here, 3. This becomes a 9. This becomes so you have one more thing to carry. Okay, so basically this will become a 0, and this will become a 1, and this is a 4, right? So this is your answer, 3104. Just let me recap that. It's a very useful method for multiplication. You get your answer much faster, and I can assure you will be 5 to 10 times faster than you following the traditional method. Okay, so listen to this very carefully again, one more time. Okay, so for the units place, you multiply all the digits together here. So you get a units place, you get 15. For the tens place, I take this one, forget this number that is closest next to it. I multiply the other two digits and I go one by one down. Okay, 1 into 4 into 6. So, sorry, that's the hundreds place. So I'm finding the tens place, right? So I take 2 into 3 into 5, right? 2 into 3 into 5, right? Plus 4 into 1 into 5, 1 into 5, right? Plus 6 into 3 into 1. So I got 68. Hundreds place, I find out by, obviously if I multiply two tens, I will get my hundreds place, right? With the units place going to be the same. So I get my hundreds place. So 1 into 4 into 6 plus 3 into 2 into 6, right? Plus 5 into 4 into 2, right? So that's how I got a 100, right? And then for the thousands place, I got 2 into 4 into 6, which is a 48, right? So this 48 doesn't come with a carry. I have to write it. The last digit, whatever you get, there's no carry there. It's part of that whole number itself, right? There's nothing beyond it, right? So then this 48 gets added to a 10 here. This becomes a 58. This 6 gets added to this one, 6. This 1 gets added to a 8, becomes a 9, and this becomes a 5. So your answer is 58695. So you're able to see this. See the beauty of this method. One single line, right? You're able to get it. Of course, there is additional steps that you have to do, but you're dealing with small numbers. Remember, it's easy to get these. It's easy to get these. Trust me, it's easy to get these. You practice at least 5 or 6 examples like this. Take any two-digit number, multiply it. Start with smaller digits first. Take it to 8, 9 and all, have that number 8, 9, 7, 8, 9, anything above 5 as well. And then if you practice it over a period of time, it becomes very easy. So I think we are kind of done for today. Okay, so that was it, right? Okay, we covered just a quick recap of what all topics we covered. Yeah, so we did divisibility tests, all right? So it was a mix of topics that we had today, because some of these need to be clubbed. These are very small topics, so that's why I clubbed some of them together. We did divisibility. It is a beautiful ekadika plus Ekadika plus oscillation method, right? Where we're multiplying one digit, adding it to that, finding out divisibility by 7, 13, 19, 23, 38, all possible combinations that you can't do with your normal divisibility checks, right? We did divisibility by multiplication by 11. We did multiplication by 101. We did basic algebra, simple multiplication using the vertically and crosswise. And then finally we did, multiplication by of 3 two-digit numbers. Okay, so I hope you enjoyed the session as much as I do teaching you all. It was good seeing you here. We will have one more last session tomorrow where we're going to combine all the methods that we learned so far in these 17 sessions, and we'll bring it all together for you, where we'll do some practice. Each concept I will take, we will do 2 or 3 examples, and then we move forward. We'll have a 1-hour session tomorrow at 5:30. So I'm looking forward to seeing you all. So till then, goodbye and alvida.